Hey guys, this is Fraser from Thanks Smart Tutoring. Today we're going to be looking at this 8-mark, specifically HL question. So the content in this is only HL, it's about the sum and product of roots. It's a pretty, not obscure, but it's a pretty short topic, but it actually comes up quite a lot, and it's very useful actually. So to begin with, we have to prove an identity that's actually not too bad. The way I'm going to do this is I'm just going to quickly use the binomial theorem. So a quick way to do this on the left-hand side is I want to expand this bracket, right? P plus Q cubed. So I know if I draw a little Pascal's triangle, it's going to be 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. So I know it's going to be this row of coefficients because I know I'm going to have 4 terms, right? If it's the 3, you have 1 extra term. And so I have P and Q. So that means the first one's going to be P cubed plus 3, and then P goes down 1 power, so Q must go up. And then 3, P goes down, Q goes up, and then 1, Q goes up. Okay, so that's just a very quick way to do the binomial theorem. And the reason I know it's 1, 3, 3, 1 is in the coefficients is from Pascal's triangle. And I just know the general pattern that you start with the highest power of 1, and then this one goes down each time, and this one goes up each time. So here it was Q to the 0, then it's Q to the 1, 2, 3, and here it's to the 3, 2, 1, and then there's obviously a P to the 0, but P to the 0 is just 1. Okay? And then we also have the minus, and then that's 3P squared Q minus 3PQ squared, and then this is going to be equal to just P cubed plus Q cubed, because these terms, this, and this are all going to cancel. Okay? And we get that, and that's equal to P cubed plus Q squared. So that's why it's only 2 marks. It's really a one-step thing, but it's nice to be able to quickly use the binomial theorem instead of expanding and expanding. Okay, so keep that in mind, because if it's a part A and a part B of the same question, that means that we're going to have to use this. They're not just going to randomly ask us to do something. So then the question is, what do we do next? Well, they're telling us that this equation has 2 roots alpha and beta. That's just given. And then they tell us to look at this equation in terms of m and n, where it has roots 1 over alpha squared, 1 over beta squared. Quick notice, squared cubed. My mistake. So there's a cubed and a cubed, and then we have a bunch of cubed terms here. Just keep that in mind, because that's going to come back later. And it says specifically, without solving this equation, find the values of m and n. Because with solving it, it's actually very easy, because we know some equations that link alpha and beta to this, right? We know their sum and their products. So we actually can explicitly find alpha and beta, and therefore we can explicitly find, by solving the equation, and then we can explicitly find these numbers, and then we can find m and n, but we aren't allowed to do that. So you wouldn't get any marks if you did that. So what do we know? Well, we know that this equation here has roots alpha beta, so that means that the sum alpha plus beta is equal to, and the formula says here that the sum is equal to minus a n minus 1 over a n. So this means that the coefficient of the, not the first term, not the highest power, but the second highest power, minus, that's going to be minus, but it's minus 5, right? It's minus 5, so it's minus 5, that becomes 5, over, and then what's the first term? 2, the first coefficient. So alpha plus beta equals 5 over 2, and alpha beta equals minus 1 to the n, a naught over a n. So minus 1 to the n is the highest power, the order, so that's 2, so that's just going to be 1. A naught is the constant term, and then a n is again just 2. So what we get, I'm just going to simplify these a little bit, is we get alpha plus beta is equal to 5 over 2, and alpha beta is equal to 1 over 2. Now you might be tempted here to just go, oh, then we can just solve for alpha beta. But if you just write down that equation, what you're going to get is the same equation. Because alpha beta are just the 2 different values of x that satisfy this, so we aren't allowed to do that. So what else do we know? Well, we know that the sum of the roots for the second equation, in terms of m and n, the sum of those roots is 1 over alpha cubed plus 1 over beta cubed. By the way, these formulas are all in your formula booklet. Topic 2 functions, HL only. So the sum of the roots is minus the coefficient of the second highest power, so it's minus m, but this time the coefficient of x squared is just 1, so actually, it's a bit too much, Robin. It's actually just going to be minus m, and the product, so 1 over alpha cubed beta cubed is just, in this case, minus 1 to 2, so that's 1. The constant term divided by the first coefficient, but that's just 1. Okay, so this is what we have. We need to find m and n without solving. So what I'm going to do is I'm going to rewrite a couple things. So I'm going to combine these fractions for m. So when we combine them, we get beta cubed plus alpha cubed over, and then it's going to be alpha cubed beta cubed, but that's the same as alpha beta cubed equals minus m. And then we also have 1 over alpha beta cubed is equal to m. Quick thing, do we know what alpha beta is? Of course, alpha beta is 1 over 2. That means that alpha beta cubed is going to be 1 over 8. So that means that we can explicitly find n. So n is going to be 1 over 8, which is just 8. That should be the solution for n. Okay, actually I'm going to write this up over here because we're going to need a bit more space. So 1 over alpha beta cubed is equal to n. So 1 over 8 is equal to n, which is equal to 8. So that's our first solution. Now the second one's a lot more difficult, but the reason I said the first part is going to be necessary is, so we know what a over b cubed is, right? We know that that's going to be 1 over 8, so when we do 1 over that, that's just going to be 8 times beta cubed plus alpha cubed is equal to minus m. Okay, and then I want to go all the way back up here. Beta cubed plus, or p cubed plus q cubed is equal to this. And if you look at this, we have the sum and we have their product, and we know the value of these from before. So what do we write down? We write down that beta cubed from the first part, beta cubed plus alpha cubed is equal to beta plus alpha cubed, and what was it, minus 3 alpha beta, minus 3 alpha beta, alpha plus beta. And we just plug in some of the values, right? So beta plus alpha, we know that that is 5 over 2. So that's going to be 5 over 2 cubed, minus 3 alpha beta. Alpha beta is 1/2. So 3 times 1/2. Alpha plus beta is 5 over 2. Okay? Yes. So when we simplify all of this, what we get is 125 over 8 minus 3, so that's 15 over 2 times 2, 4. Beta cubed plus alpha cubed. And then when we put this in, we get that 8 times 125 over 8 minus 15 over 4 is equal to minus m. So that means that 8 times 8 is going to be 125 minus 30 is equal to minus m. So this is going to be 95 is equal to minus m, so m should be minus 95. There you go. So hopefully that made sense. These are actually quite nice where you don't explicitly find alpha and beta, but you just use the fact that you know what their sum and their product is equal to. Okay, so the formulas are a little confusing, but once you know, like, you know, a bit of polynomial notation, it's like a to the n minus 1, a naught, all of this kind of stuff. Hopefully it's pretty clear. Let me know if you guys feel like there was something else that I missed or something that wasn't clear for you guys. And as always, if you feel like you need a bit more of this kind of help, a bit more tutoring, feel free to head over to Think Smart Tutoring. There you can easily grab a tutor, you can set up your lessons, it's super flexible. Obviously the tutors have recommendations for how often you should be doing lessons, but at the end of the day, it's really up to the student, how much time they have and how much time they want to dedicate to these extra lessons. So yeah, we're making more of these videos as always. Let me know if there's something you guys want to see, and see you guys soon.